So this is my CPE403 final project. It's a BeagleBone. It's implementing a BeagleBone as a sub-gigahertz gateway. So the main goal is to obviously implement a BeagleBone as a sub-gigahertz gateway. In order to do this, I had to use two CC1350s. One was going to be interfaced with the BeagleBone, and the other one was going to be reading data from an accelerometer. The data that's being read from the accelerometer will then be transmitted to the other CC1350, which is attached to the BeagleBone, and then the BeagleBone will upload the data will upload the data from the accelerometer into the cloud server, which in this case was ThinkSpeak. So the outcome was basically me shaking an accelerometer like crazy and getting multiple values, getting the X and Y, Z axis to change repeatedly, and then upload it to a cloud server. The components used in this design is an LIS3DH, which is an accelerometer. The URL, the product that I use can be found in this URL. ThinkSpeak was the application that I used to upload the data. Two CC1350s, one to interface with the BeagleBone and one to read data from the accelerometer, and a BeagleBone Black. Some tools I needed to accomplish this project was Etcher. Etcher basically was used to burn my SD card. Code Composer is to program the CC1350 VirtualBox, so I can expand my SD card, so I can expand the firmware, the Linux image I burnt using Etcher. Ubuntu, which is the OS that I chose, and CyberDuck to transfer files between different machines. Here's my schematic. It's very basic. It's just one CC1350 interfaced with a accelerometer, which spits out the data via Bluetooth or BLE mode, and the other one receives the data which the CC1350 spit out, and then transmits to the BeagleBone via UART. And the BeagleBone's job is just basically to upload the data to ThinkSpeak. Prerequisites required in design. You need two CC1350s, one accelerometer, which is the LIS3DH, and one BeagleBone. A virtual machine with any Linux-based operating system. You need Python 2.7 or above, and PY serial installed on your BeagleBone Black. You need some cape overlays for your BeagleBone Black. UART1 needs to be enabled, and here are the commands to install all the prerequisites. So it's very simple. You just need to update and then upgrade your BeagleBone, and then install the cape overlays, and then go into as a root user, and then just enable UART1. So implementation details. Obviously you need to download Code Composer in order to flash your CC1350s. Aside from using Code Composer, you also need to download the Simple Link CC13X0 SDK library, which can be found in Resource Explorer once you have Code Composer, or you can find it and TIA's website. I just attached the URL. After you've installed Code Composer, you need to, so what I basically did was get an example code or project from Code Composer that uses the CC1350 and that uses the real-time operating system in order to get the real-time operating system project. you need this project to use the real-time operating system. A continuation to the CC1350. Once the transmission project has been flashed, close the project, import the receiving project, and then flash. So this basically says that you need to flash the transmitting CC1350. The transmitting CC1350 is basically the one that's being interfaced with the accelerometer, and the receiving CC1350 is the one that's interfaced with the BeagleBone. You need to flash both CC1350s with the appropriate project. And then to test it, you can just have the CC1350s connected to a PuTTY terminal just to test if it's actually receiving any data. So in order to implement the design, like I previously said, you need to flash a Linux image on your SD card. I used Etcher. Once you've flashed this SD card with a Linux image, you boot up the BeagleBone with the SD card. You basically have to push down the boot button to boot up the BeagleBone using the SD card. Once that's done, you update all the libraries that are installed on the Linux image already. You update and you upgrade. You make sure you have BeagleBone's cape overlays. And then you install. If you don't, you install the BeagleBone cape overlays. Once you're done, you enable UART1. After that, yeah, you're good to go to connect the CC1350, which will interface with the BeagleBone. And then for setting up ThinkSpeak, you just need to create a new channel with 3 fields. And then once you've set up ThinkSpeak, all you need to do is run the Python script that I created in order to upload data to ThinkSpeak. This is the image of the actual project working. As you can see, the CC1350 above the BeagleBone is the one reading the data and then transmitting it to the CC1350 to the left of the BeagleBone, which then that CC1350 transmits data via UART to the BeagleBone. This is the URL to my demo video. I'll let you guys watch that. So results and conclusion, everything went smooth. As you can see, this is just one of the graphs from the accelerometer. I have 3 graphs, an x-axis, a y-axis, and a z-axis. This graph is actually for the x-axis, and it's actually averaged out. I believe, yeah, I have it averaged out. And then the image to the right is just the BeagleBone's terminal. It's just the values being read in and then spit out to ThinkSpeak. And here's the rest of the graphs. And if you want to see them like for yourself, there's a URL to the ThinkSpeak. Thank you. I love you, Venki. Thank you.